Hi, everybody. I hope everybody's staying healthy and uh, not being driven too crazy by having to stay in all the time. But the good news is, this is the last thing you have to do this year for physics. And what you're going to start with is you're going to watch this video review. And you're already watching it because you press play. And then you're going to take your test. You can use notes, textbook, Google, whatever you want. I want you to take the test anytime between now and midnight this Friday, the 22nd. And there are 16 questions. You only need to answer 10 of them. So you can answer 10 and then stop, or you can answer 12 or 16, and I'll take your best 10 scores, and that'll be your last test and your last grade for this course. And how it's going to work is, so first of all, let's do the review. So this is question one, and I'll ask you the question, and then I'll stop talking for about 5 seconds, give you a chance to pause the video and try to figure out what the answer is. And then you press play again, and I'll explain I'll give you the answer and explain how to find the answer. All right, so let's try this one. Question one, what is the total resistance in this circuit? Well, you can see it's a 12-volt source, and there's two resistors here, a 6 ohm and a 12 ohm, and they are in series. So to find the total equivalent resistance in series, all you have to do is add them up. So 6 plus 12 is 18 ohms. Question two, how much current flows through resistor 1 in the same circuit from before? All right, so to find the total current, we already know that the total voltage is 12 and the total resistance is 18 ohms. And we just use Ohm's law, and current is voltage over resistance, so 12 divided by 18 is 0.67 amps. And that was for resistor 1, but remember for series circuits, current is the same, so it's 0.67 for resistor 1, it's also 0.67 for resistor 2. Question 3, which resistor would produce the most heat? So you got to think about this one, but just try to think about which one of these two would heat up the most. Okay, remember, it's a series circuit. The current is the same at both resistors because the current has no choice but to pass through both of them. There's no other path for the electricity, for the electrons to get from the one end of the battery to the other. And we had reading at the beginning of this unit, um, the resistor with the highest value would resist the flow of that current the most and heat up the most. And if you want to kind of have an analogy to prove this to yourself, if you put your hands together, don't push too hard, just kind of loosely put your hands together and you rub them back and forth, or your hands will warm up. Okay? And that would be like resistor 1, just a little bit of resistance. But if you push your hands together harder, put more pressure on there and rub your hands together, like resistor 2, more resistance, more friction, your hands heat up more. It works the same for electrons moving through a resistor. The more resistance, the more heat. So resistor 2. Question 4. What is the total resistance in this circuit? All right. Well, again, you want to break these two down and combine them into one equivalent resistor. But these two are in parallel. So you can't just add them up. You have to take the reciprocal of the sum of the reciprocals. So it would be 1 over 9 plus 1 over 6, and you get like 0.28. You take the reciprocal of that, and it's 3.6 ohms equivalent resistance. Question 5, what is the voltage drop across resistor 1? So what is the voltage at resistor 1? Well, we know that our equivalent resistor, this 3.6 ohm resistor over here, this was actually two resistors in parallel. Now we know that for series circuit, current is the same, but for parallel, voltage is the same. So right here, this one resistor had 18 volts. That means these two in parallel are both 18 volts. Question 6, how much current flows through resistor 1 in the same circuit? Okay, we know that at resistor 1, it's 18 volts and 9 ohms of resistance. Well, we have volts, we have ohms, we can use Ohm's law. So it's 18 divided by 9, or 2 amps. And we could go ahead and figure it out for resistor 2. It would be 18 volts divided by 6 ohms, or 3 amps. Question 7. If the resistors were light bulbs, which would be brighter? Well, remember, we did have reading before, and again, I just want you to think about this. Resistor 1 has 8 volts, 9 ohms, and 2 amps of current passed through it. Resistor 2 is 18 volts and 6 ohms, so 3 amps of current flow through it. So resistor 2 has actually more electric current flowing through it because it has a lower resistance. So more current means resistor 2 would be brighter. Question 8, which two arrangements of resistors have the same equivalent resistance? So you have Roman numeral 1, 2, 3, and 4. Which two of those have the same total equivalent resistance? Okay. If you look at 1 and 2, they're both in series, so all you have to do is add up their resistance. So Roman numeral 1 is a total of 4 ohms. Roman numeral 2 is a total of 5 ohms. Circuits 3 and 4, they're parallel, so you've got to use the reciprocal rule. So 3 would be 1 over 2 plus 1 over 2. So 1 half plus 1 half is 1 whole, and the reciprocal of 1 is 1. So 1 ohm of resistance for 3. 4 is 1 over 10 plus 1 over 10, so that's 0.1 plus 0.1 is 0.2. The reciprocal of 0.2 is 5. So circuits 2 and 4 have the same equivalent resistance. Question 9. Again, this is nothing we've directly done in the work you've been doing for the last few weeks, or several weeks. Has it been that long? Okay. Question 9. The 4 resistors shown below have the lengths and cross-sectional areas shown and are made of the same resistive material. Which has the least resistance? Okay, there's different ways to think about this. A good analogy for electricity flowing through wires is like water flowing through a pipe, because it is electrons actually moving through something that's resisting the flow, just like water moving through a pipe. Okay, and if you think about it, it's resisting the flow of electricity. So the longer resistors would have more material to resist a longer distance to resist it. So certainly the two longer ones, Roman numeral 1 and Roman numeral 3, they're longer, so the electrons have to flow through it for a greater distance, so they're going to have a greater resistance. So the answer is either 2 or 4. And this is where the water analogy through a pipe comes in handy. A smaller pipe would let less electricity through. A bigger pipe, a wider pipe, would allow more electricity to flow through. Okay, so what you want is a shorter, thicker pipe for water, or a shorter, thicker resistor for electricity. So number 4 has the least resistance to the flow of electrons. Question 10, what is the total equivalent resistance in this compound circuit? All right. Remember, we've got a resistor here, resistor 1, 3 ohms, and then there's a spot here where the electrons can have a choice to go through resistor 2, a 1 ohm, or through resistor 3, a 3 ohm, join back up, and then go to the end of the battery. We can't just combine them all together because resistor 1 is in series with this parallel combination. So we've got to do resistor 2 and 3 first. And that's the reciprocal rule. 1 over 3 plus 1 over 1 is 1.33. You take the reciprocal of that, and it's a 0.75 ohm equivalent resistor. Now those two are in series, so you can just add them up and get that this 6-volt circuit feels a total equivalent resistance of 3.75 ohms. Question 11, what is the total equivalent resistance in this circuit? Well, all right. This one you got to think about, but give it your best shot. It's a 20 ohm resistor that is in series with these two resistors that are identical in parallel. You're given that the total current is 1 amp and the voltage is 30 volts. Well, now we need to combine it down into one equivalent resistance first. You got to find that total resistance and that total current. Okay, so well, we have that the total voltage is 30. You don't even have to break them down here. The total voltage is 30, and the total current is 1 amp. So we can use Ohm's law and rearrange it. Current is voltage over resistance. So resistance is voltage over current, or 30 over 1. And so the total resistance must be 30 ohms. And you would get that 30 ohms by adding 20 to the equivalent resistance of these two. So if I take my 30 and I subtract the 20 ohms, I'm left with 10 ohms. So I know that these two R's in parallel must be a total equivalent resistance of 10 ohms. If you rearrange the reciprocal rule, 1 over equivalent is equal to the sum of them. That would be 1 over 10 is equal to 1 over R plus 1 over R, or 1 over 10 is equal to 2 over R. So you can divide the 2 out, take the reciprocals, and find that that both R's are 20 ohm resistors. That was a tough one, wasn't it? Okay, one more. What is the total current in this circuit? So you've done this for me before in homework. Just give it a shot. All right, so you need to condense this down to one equivalent resistor, use the voltage, divide by that resistance to find the total current. Okay, you can first combine resistors 2 and 3, so 1 quarter plus 1 quarter is 1/2. The reciprocal of that is 2. So now you'll have a series of 5, 2, and 2, or a total equivalent resistance of 9 ohms. Current is voltage over resistance, so 12 divided by 9 is 1.33 amps. Okay, so your first thing was to watch this review video, follow along. You did that. Now you're going to go back to the Canvas page for today, click on the test, open it up. Remember, you only have to, sometime between now and Friday, and you know that you only need to answer 10 of the 16 questions. All right, let's finish out the year strong.